Hey there, Mr. Weaver here, and this is 8th grade Module 2, Lesson 1, Terminating and Repeating Decimals. After this lesson, you need to be able to show how the decimal form of a rational number repeats eventually and convert a repeating decimal into a rational number. Let's learn. Rational numbers. When you first learned to count using numbers, like 1, 2, 3, 4, etc., you were using members of the set of what's called natural numbers. When you add 0 to that set, you end up making the set of whole numbers, and then whole numbers and their opposites, so now bringing in the negatives, make up our set of integers. All three of those together are part of the set of rational numbers. And rational numbers are going to also include your fractions and some of the decimals. So rational numbers are numbers that can be written as the ratio of two integers, where the denominator is not 0, because we can't divide by 0. Which is why fractions are part of the rational numbers, since we're expressing our number as a fraction. We can see in our model here, we have the rational numbers encompassing all three of the things that you've learned about before: integers, where your negatives are involved, whole numbers, which include 0, and then natural are your normal counting numbers. The rational numbers outside not only include all the things inside, but also your fractions, some decimals, and then here they even put as a percent, since we could write this as a fraction, such as 18 over 100. That would be 18%. So when we're talking about rational numbers, we're talking about all of these types of things. Let's learn. Terminating and repeating decimals. Every rational number, so all those that we just saw, can be expressed as a decimal by dividing the numerator by the denominator. The decimal form of a rational number either terminates in zeros or eventually repeats with a different number. Repeating decimals are decimals in which one or more digits repeat. They make a pattern. If the repeating digit is 0, then we say that the decimal is a terminating decimal. If it's something other than 0, then we're going to say that it's a repeating decimal. When we have repeating decimals, bar notation is used to indicate that a digit or group of digits repeats. So the bar is placed above the digit that repeats. So here we have 0.833333333, so on. The 3 is what's repeating over and over. It's the same number pattern over and over. We would write the part that repeats with a bar over it, so this would be shortened to 0.83 with a bar. And you might hear it said as 0.83 bar or 0.83 repeating. When a rational number is expressed as a decimal and the repeating digit is not 0, the decimal does not terminate. So zeros terminate, not zeros do not terminate, they repeat. So here we have two numbers, 2/5 and 5/6. Let's look at what part starts to repeat, and then we'll decide if that's a terminating decimal or repeating. So if we divide 2 by 5, we end up with 0.4, and then 0, and 0, and 0, and 0. If we divide 5 by 6, we end up with 0.8, and then 3, and then 3, and 3, and so on. We keep getting 3s. So we could write this one as 0.83 with a bar over it. Do these terminate? Well, this first one, after we see this first 0, and then we see a 0 again, we can realize that no matter what, we're going to have 0. This is like having no remainder. So we would make it a terminating decimal, and we would cut it off without those zeros. So this would be 0.4, or 4/10. For the second one, we already decided that the 3 had a repeating pattern, so this one does not terminate, it repeats. So the key here, if it ends in zeros, it's going to be considered terminating. If the repeating number is not a 0, it's going to be repeating. Take a minute and try to sort these into ones that terminate into zeros or do not terminate in zeros. Pause the video now and place them where you think. Let's go through. 0.64000, I can see my groups of zeros here. So this one I would write down here, and I'm just going to cut off the zeros. So 0.64. 0.84 already has the zeros cut off, so it also would terminate in zeros. If a decimal ends, that means it ended in zeros. So here we have 0.56, also ending in zeros. 0.333. This one, my repeating number is not 0, so it does not terminate in zeros, it repeats. 0.333, 0.4242, and so on. I have a 4-2 pattern over and over. It's not a pattern of zeros, so this would go down here in the not terminating in zeros. And then finally 0.7, that ended at the 7, so I'm going to write it over here. Example 1, write fractions as decimals. Write 5/8 as a decimal, then determine whether the decimal is a terminating decimal. So in order to know if things are terminating or repeating, we have to change our fractions into decimal form. So to do that, we're going to divide the numerator, or the top, by the denominator, which is the bottom. So 5 divided by 8. 8 goes into 5 0 times. 8 goes into 50 6 times, and 8 times 6 is 48. Subtract, we have 2 left over. Bring down the 0. 8 goes into 20 twice, which is 16. Subtract, we have 4 left over. Bring down the 0. 8 goes into 40 exactly 5 times. We have a remainder of 0. When we get to a remainder of 0, not that it can go in there 0 times, when we get to a remainder of 0, then that's our clue that we're going to be terminating in zeros. If I plugged in 8 to 0, it would go in there 0 times. Even if I brought down another 0, 8 is going to go into 0, still 0 times. It doesn't matter how many zeros I would add. I can see that it's starting to be there 0 times. So 5/8 comes out to be 0.625, 625 thousandths. Now that we know our decimal form, so 0.625, we're deciding if it's terminating or repeating. So the repeating digit here was 0, right? We started getting zeros at the end. So if we were to continue to divide, it would still be 0, 0, 0, 0, 0. Because the repeating number is 0, this is a terminating decimal. And we should just cut it off once we get to the 0. Check your understanding. Write -2/9 as a decimal, then determine whether the decimal is a terminating decimal. When you're dividing with a negative fraction, just divide the fraction like normal, so 2 divided by 9, but then make your answer negative. Pause the video now and complete this check. Check your answer. The decimal that's equal to -2/9 is -0.2 repeating. If we do 2 divided by 9, add some zeros, 9 goes into 2 0 times, so there would be our decimal. 9 goes into 20 twice, which is 18, and we have 2 left over. If I bring down, 9 goes into 20 twice, and I get 18. You should be able to start seeing the little pattern here already. 20, 18, 20, 18. If I do it again, it would be 20, and then 18. So I would keep getting 2s. I'd have 2 left over every single time, making it back into 20. I end up with 0.222, and so on, which means that it's 2 with a bar over it. Is this a terminating decimal? It is not terminating. It is repeating because 2 is the digit that repeats, not 0. Example 2, write mixed numbers as decimals. Write -1 2/3 as a decimal, then determine whether the decimal is a terminating decimal. So first, -1 2/3, we should rewrite it as -5/3 in that improper fraction. So that way we can divide 5 by 3, and at the end we'll just add our negative sign. 3 goes into 5 1 time, subtract, we have 2 left over. 3 goes into 20 6 times, so 3 times 6 is 18, we have 2 left over. Now if I bring on another 0, I'm at 20 again, which means I would subtract 18, which is a 6. I'm seeing my same pattern here, again, with my 20s and my 18s with 2 left over. I'm seeing that pattern, it's going to keep going. -1 2/3 is equal to -1.6 repeating, or 1.6 with a bar over it. No matter what, the remainder will never be 0. That's an indication of repeating. That's an indication of repeating with a number other than 0. So it would be a repeating decimal. Now, second part of this was determining, is it a terminating decimal? The repeating digit was 6. Because that digit is not 0, it is not a terminating decimal. In fact, it's a repeating decimal. Check your understanding. Write 4 13/25 as a decimal, then decide, is it a terminating decimal? Pause the video now and complete this check. Check your answer. First, the decimal of 4 13/25 is 4.52. Another way to divide with mixed numbers is just to divide the fraction and then make the decimal part whatever's out front here. So I know it's going to be 4 point something, whatever this fraction is. So 13 divided by 25, that goes in there 0 times. If I add a 0, that goes in there 5 times, and it would be 125. With 5 left over, bring down a 0, goes in there twice. Exactly 50. I have no remainder. 5/2 was my ending part. Is this a terminating decimal? Yes, I got a remainder of 0, which means I can end it after 0.52. It terminated. It is a terminating decimal. Or I could keep dividing and get a bunch of zeros and check that it's terminating that way. Let's learn. Write repeating decimals as fractions. Write a repeating, non-terminating decimal, such as 0.4 repeating, as a fraction. So here, we are working our way backwards instead of starting as a fraction and checking to see if it's a repeating decimal. We know that it's a repeating decimal, and we need to figure out what the fraction is. So to do this, we're going to end up multiplying, subtracting, and then dividing. And it's kind of be the same step for no matter what the repeating decimal is. So first, we're just going to say that some letter, usually they use the capital letter N here, is the repeating decimal. So I wrote it out, 0.444 repeating, and so on. Then you're going to multiply by 10 for everything that's different that's repeating. So in this case, only one number is repeating, so we would just multiply by 10. If there were 2 digits that were repeating, we'd have to multiply by 100. If there were 3 digits repeating, we'd have to multiply by 1,000, and so on. So here, 1 digit was repeating, so we're going to multiply by 10. When we do that, we now have 10 of the variable equals, this is now moved one place over to the right. So by doing that, we end up with some number in front of the decimal as part of that repeating pattern. Once we've multiplied and moved our decimal place, the appropriate number of spots, we're going to subtract the original equation up here. So here we have subtracting n from the left side and subtracting our repeating decimal from the right side. What this does, it ends up getting rid of all of that repeating part at the end, and you're left with what's just in front of the decimal. So I end up with a 4, which was in front of the decimal, and then subtracting n, so 10n minus 1n gives me 9n. My final step, divide both sides by the number that's in front of the variable, so dividing by 9, I end up with n equals 4/9. I don't want to divide this part because I'm turning it into a fraction. I want to leave it showing the division. So my number, which was equal to my repeating decimal up here, that same variable is equal to fraction of 4/9. So 0.444 repeating is equal to 4/9. Example 3, write repeating decimals as fractions. So write 0.5 repeating as a fraction in simplest form. So again, we're going to go through our process. Let's say n is the repeating decimal, so 5 repeating. Only 1 digit repeats, so we have to multiply by 10. Once we multiply by 10, we get 10n equals 5.5 repeating. Subtract the original, so minus n, I get 9n. Take off the repeating part, and I end up with 5. So my final thing, I would do 5 divided by the number in front of n, so 5/9. 5 repeating is equivalent to the fraction of 5/9. Check your understanding. Write negative 0.7 repeating as a fraction in simplest form. Again, just because it's negative, make your answer at the end negative, but do everything else as if it was positive. Pause the video now and complete the check. Check your answer. You should have said negative 7/9. So I'm going to follow the same process here. N is equal to 0.777 and so on. 7 repeating. I'm going to multiply it by, there's 1 digit repeating, so I got to multiply by 10. 10n equals 7.777 repeating. Take away the original. So I'm subtracting both things. I have 9n equals 7. Divide both sides by 9. N is equal to a fraction. And it was negative in the problem, so I need to make it negative as my answer. Example 3, write repeating decimals as mixed numbers. So write 2.18 repeating as a mixed number in simplest form. The process for this one is the same as we had just done. So we're going to assign a letter to our original expression. Here you can see we're multiplying by 100 because there are 2 numbers that repeat this time. 1 and 8 both repeat, so we have to multiply by 100, which has 2 zeros. This moves the decimal 2 places over to get 218, and then 18 still repeats. Just like we've been doing, we're going to subtract our original. When we do that, 100 minus 1n is 99. 218 minus 2.18, that's not lined up very nicely here, but we would get 216. Remember, we got to line up our decimal point when we're subtracting. Again, the repeating part eliminates when we are subtracting, so 218 minus 2 is 216. Last, divide both sides by 99. So I would end up with 216 divided by 99. Here we got to turn it into a mixed number. So 99 goes in there 2 times. I know it's going to go in there 2 because in the problem it's 2.18. So if I pull 99 out there twice, that's 198. So pull out 2. out of 99. I pulled out 198 out of the 216, which means there's 18 left. And then I can reduce 18 out of 99. I can divide the top and the bottom both by 9. So if I divide the top by 9, I get 2. Divide the bottom by 9, I get 11. So I end up with 2 and 2/11ths, which was our answer. So 2.18 repeating is 2 and 2/11ths. Check your understanding. Write 1.42 repeating as a mixed number in simplest form. Pause the video now and complete this check. Check your answer. You should have said 1 and 14 out of 33, or if you didn't reduce this, it would be 42 out of 99. So let's look at how to get this. First, this time, I want to show you how we can do it without the 1 out front. So I'm going to pretend that the 1, I know that the 1 is already in the answer. Let's figure out what 42 repeating is as a fraction. So I'm going to say n is equal to 0.42 repeating. I have 2 digits repeating, so I need to multiply by 100. So 100n equals, move it twice, I have 42.42. Still repeating, so there's another 42 there. Subtract my original, subtract my 0 point there, so 42. I end up with 99n equals 42. My repeating part is gone. Divide by 99. There's my fraction, 42/99. I can divide both of these by 3. So 42 divided by 3 is 14. 99 divided by 3 is 33, which gives us our fraction part. And we already took the 1 off, so we just attached the 1 back out front. So 1 and 14 out of 33.